Okay, in this video we are going to learn how to enable auto-rotation for secrets in AWS Secrets Manager. This video has been requested from one of my viewers, which makes it even more interesting to make it. I'm sorry for not posting any new videos for a while now, but I'll try to make it up to you with this one, which is rather long compared to my other videos, and some other interesting ones coming up. Rotating secrets like database passwords, API keys, etc. are generally considered good practice. It provides an extra level of security. Let's say the password to your database are accidentally added in version control, and it goes undiscovered for some time. At some point later, a person with ill intent found the password in the commit history. Then it would be great if the password was no longer usable. If you hadn't enabled auto-rotation, then maybe this password would still be usable, and that person could be able to compromise your database. Of course, the malicious person could have found the password before it was auto-rotated, but you are at least reducing the risk of that being the case. So, how do we enable auto-rotation of secrets stored in AWS Secrets Manager? Well, first we need a secret that we can auto-rotate. I'm going to enable auto-rotation on a secret that I have already created. But you can just as well enable auto-rotation when you are creating the secret. If you don't already have one and want to know how to create a new secret, as well as how to make use of it, watch my video linked above. Now go over to AWS Secrets Manager. Here you can see my secret, which I've called my API key. This secret is of type other type of secret. This is, for example, useful for API keys. It could just as well be any type of secret, like an Amazon RDS database, etc. Auto-rotation would work for that as well. If I open the secret and click on Retrieve Secret Value, you can see that the value is test123. If we are successful, then the value should change to a random string value by the time we are done. If we look under rotation configuration, you can see that rotation is disabled for this secret. We are going to enable this right now. Click Edit Rotation. Enable auto-rotation by flipping this switch. Next up is the rotation schedule. Here you can choose between Schedule Expression Builder and Schedule Expression. I'll choose Schedule Expression Builder for this example. But just to show you the alternative, here you can either use a cron expression where you define, for example, each Monday or every first date of the month, etc. Alternatively, you can use a rate expression where you define a rate, for example, 10 days. Now, back to the Schedule Expression Builder. I want to rotate using weeks as time unit and an interval of 2 weeks. Next up is the day of the week. I'll let this be Monday, and I want this to happen at night, so I'll set it to 2 AM. Keep in mind this is a 24-hour clock. You can also add a window duration if you want. Also, I want the secret to be rotated immediately, so I'll leave this box checked. Next up, the rotation function. You see, we need a Lambda function to perform the actual secret rotation. And since we don't already have one, we need to create a new Lambda function. To do this, we can either use a template from the serverless app repository, which I'll link below, or create our own from scratch. We are going to do the latter, just for learning purposes though. Still, the code I'll write is heavily inspired on a template made by AWS, which I'll also provide a link to. As you can see, Secrets Manager suggests a random Lambda function I have created previously, but this can't be used for this purpose, so I'll create a new one. Click Create Function. We'll now be redirected to the AWS Lambda console, and here we can create our new auto-rotate function. Now give it a name. I'll call mine Rotate Secret. Next, I'll choose Python as language, of course. If you didn't already know, this is just because it's my favorite programming language. Next, click on Create Function. This will just take a moment, and now we can start writing the Lambda function code. Before we continue, if you find my videos interesting and want to learn more about serverless and AWS, please consider subscribing to my channel and smash that bell icon to get notified when I publish more content. The code I'll write here is a simplified version of the one you can find in the AWS documentation. I haven't found any good description of this code anywhere, but I'll try to do my best to explain it. And the syntax may not be the best, so bear with me. First off, let's just delete all the example code. As you probably know, the Lambda handler function is the entry point for an AWS Lambda function. And this time, the event object contains 3 parameters, which we'll need to extract: secret ID, client request token, and step. So let's start by writing the code for extracting these 3 parameters into their own variables. First, create an ARN variable for the secret ID. Then a token variable for the client request token. And lastly, one for the step parameter. Next up, import Boto3 since we are going to need this to communicate with Secrets Manager. Now use Boto3 to create a Secrets Manager client. We'll use this later on to call the Secrets Manager service. Okay, so what you should do now is to do some validation, like validating if the secret has rotation enabled, making sure that the status of the secret version is set to pending, etc. I will not do this in my example, and this is just for simplicity. You should implement extensive validation if you plan on using this in a production environment. Take a look at the example linked below to see how you potentially can do that. The only validation I'll do is to make sure that the secret has versioning enabled. To do this, we need some metadata about our secret. Create a metadata variable and use the Secrets Manager client to call describe secret. Provide the secret ID or ARN as the parameter. I'll then use the metadata object to see if rotation is enabled. If not, then I'll raise an exception of type value error and provide a message saying something like secret is not enabled for rotation. Next up, we need to validate the value of the step parameter or variable. You see, in the process of rotating a secret, Secrets Manager will call this function 4 times, each time with a new step value. Secrets Manager calls the Lambda function 4 times due to the fact that rotating a secret is a 4-step process. This means that the step property will change each time the function is called. It'll be create secret, set secret, test secret, and finish secret. You may wonder what all these steps are for. Well, create secret is actually creating a new secret version with a new value. setSecret is for updating your potential credentials in your database to reflect the new value of the secret. For example, calling MySQL server to update the password. TestSecret is, as the name suggests, calling whatever service you want to verify that the new password does work. Lastly, FinishSecret is for moving the AWS current label from the previous secret version to the new one. Okay, now we'll write the code needed to differentiate the 4 different steps. First, I'll print the value so that we can see it change for each time the function is called. Next, I'll use a simple if, elif, and else check for createSecret, setSecret, TestSecret, and FinishSecret. Oh, I almost forgot. The else statement has to be something that raises an exception, since we will only allow these 4 steps. So what we need now is to write a function definition for each of the 4 steps. And all these functions should accept 3 parameters: the Secrets Manager client, the ARN of the secret, as well as the token. So write one function definition called createSecret, and then one called setSecret, one for test_secret, and lastly finish_secret. Inside each conditional statement, call the function for that specific step. We can now implement each of the function we just defined. First off, the createSecret function. Make sure you have all the 3 parameters defined. Use the Secrets Manager client to call getSecretValue with the secret ARN and the version stage set to AWS current. This is to make sure that the current secret exists. Next, write a try_except block, and inside use the Secrets Manager client again to call getSecretValue. This time with the version ID set to the token value and the version stage set to AWS pending. We expect this to fail and raise a Secret Manager resource not found exception. This is because we have not yet created a new secret value. If for some reason there should exist a version with AWS pending at this stage, then this could indicate that we have a previous attempt of creating a new version that has failed, or that there is another process running simultaneously that are updating this secret. And if that's the case, then we don't want to create yet another version. I'll catch this exception here and write a password variable which is going to be my new secret value. I'll use a built-in function from Secrets Manager to assign a random string value to my new password variable. To do this, use the Secrets Manager client to call client.getRandomPassword with exclude characters set to whatever you want to exclude. This is to make sure that the new secret doesn't violate any password restrictions provided by the service or application that are going to use this secret. Next up, use the Secrets Manager client to store the new secret version in Secrets Manager. Call putSecretValue and provide the secret ARN, the client request token, the secret string, which we'll extract from the password variable, and lastly set the version stage to AWS pending. Perfect! We now have the logic for creating a new secret version in place. Let's implement the setSecret function. This is going to be easy, since I'm not going to implement it. The reason why is that I have no service like a database that require a copy of my new secret value. The same goes for the test secret function. I will not test it against any service or application for the sake of simplicity. You should do this, of course, for your production applications. Lastly, the finish secret function. As the last step in rotating a secret, we need to make our new secret version the current one. This is done by moving the version ID, AWS current, to our new secret version, which currently has the version ID, AWS pending. To do this, we first need to retrieve the metadata of our secret. Define a new metadata variable and use the secrets client to call describe secret with the secret on. Next, we need to loop through the versions inside the metadata versions to ID stages list. And inside the for loop, write an if statement to look for AWS current in each version. And inside that if statement, write another to compare the current version with the provided token. If they are equal, then the new version is already marked as the current one, and we can write an empty return statement to exit this function. Now, if the current version and token is not equal, then we need to use the secrets client to call update secret version stage to move AWS current to the new version. This function requires 4 parameters. First, the secret ID, which is the secret on, then the version stage, which is AWS current, then move to version ID, which should be the provided token, and lastly remove from version ID, which is the current version. Just to exit the for loop, we can write a simple break as well. The code should now work, but we still need to add some IAM policies. Find the Lambda function execution role by opening the configuration tab and choose permissions. From here, open the IAM role. Once here, click Add Permissions and Attach Policy. I have already created a new custom IAM policy called Rotate Secret, which is based on one in the AWS documentation for rotating secrets in AWS Secrets Manager. I'll provide a link to that as well. Okay, the policy is now attached, and we can go back to the Lambda function. Now we need to grant Secrets Manager access to invoke our Lambda function. To do that, open the Configurations tab again if you haven't already, and choose Permissions. Scroll down to Resource-Based Policy. Here, click Add Permissions. Choose AWS Service since it's another service in the same account we want to grant access to. Then choose Secrets Manager as Service. Give the statement an ID. This can be anything that makes sense for you. Let Principal be as default. And under Action, choose Invoke Function. Lastly, hit Save. Go back to the code window and hit Deploy. Now the function should be ready to be used by Secrets Manager. We just need to finish the configuration of our secret. Go back to Secrets Manager and under Rotation Function, click the Refresh button. Now choose our Lambda function and hit Save. If we now try to retrieve the secret once more, we can see that it has changed. This means that our rotation function did exactly what we wanted, and in 2 weeks it will change again, and so on. I have not yet decided on the topic for my next video, so I'll let that be a surprise. I've gotten some requests for new topics, so maybe it's the topic that you have requested. Until next time, happy coding!